In this lesson, we're going to be talking about how to apply our lesson 4 generalized random complete block design into JMP. But before we do that, I want to talk about if we have a randomized complete block design, like our insecticide example from lesson 3, and we applied a generalized random complete block analysis on it. So, as a recap, our insecticide example, we were a researcher that was conducting an experiment and we were trying to compare the effect of 3 different insecticides to get enough data. It was necessary to use 4 different plots where each plot was subdivided into 3 rows. That's where we apply our treatment. Okay, and again, this isn't a generalized random complete block design because we only have 1 replicate per treatment block. Okay, so if we come to our insecticide, we click how we would typically do it because our model in a RCBD, we have our treatment and we have our block. So let's look at remind ourselves of how we would do it properly. We'd go to Analyze, Fit Model, our Y and our response. You can click on one, Shift, and then Add, and I'll add both of them. Click Run, and we get our ANOVA and our estimate effects. You could do your contrast by coming up here and do your post-analyses. Okay, so now let's see if we took our insecticide, which should follow the RCBD, but we now use the generalized random complete block model. So we're going to put in an interaction term. Let's see what JMP is going to give us. So how we would do that is we're going to go here, we're going to Analyze, Fit Model. Our Y is still our response. I'm going to click Shift, Up, Add, just to get our block treatment. This would be the right analysis for this, but we're going to make it wrong. You're going to click Shift and then click the other one. And now you're going to press Cross. And so this is going to get us the interaction effect. Now we're going to run it, and what you're going to notice is we're going to get a bunch of no points in a sense, and we actually by default it doesn't give us the ANOVA table. So if we click up here, regression reports ANOVA, you're going to start to notice that we have 0 in the error. Our parameter estimates, really there's no error around it. And so what's happening is what should be in this error term is this 6 is our interaction. But we're trying to also estimate it. So we aren't able to properly estimate this example because we don't have replications. We need replications in order to estimate this interaction. And so this is what JMP will give you if you try to apply a randomized complete block design, but you analyze it using a generalized random complete block design. Now, let's get back to our reaction time, so we'll get rid of that. And so let's recall what our reaction time was. We were studying the reaction time under the influence of alcohol. Age is thought to be another factor that could affect time. We had test subjects in the 3 groups, and in each age group, each treatment, 0 ounce, 1 ounce, 2 ounce, was randomly assigned to 4 individuals. So we have replication. And this is going to, again, allow us to compute this block treatment interaction. So let's see how we get this ANOVA table. Always want to click on your data in JMP. We're going to go to Analyze, Fit Model. Time is going to go into our Y. Our alcohol, Add. Age group, that's our block, Add. And again, to get the interaction, you're going to click on one, you're going to press Shift, Up, Cross. And now we're going to run. And so notice that we have our ANOVA down here, we have our degrees of freedom, our sums of squared error, our MSE right here. Again, MSE is the variance, so if you wanted standard deviation, you would have to square root this term. If you want your mean squared results in your ANOVA, you're going to right click on the table, columns, mean squared, and then you get your mean squared. Again, recall that alcohol is our treatment and our age group is our block. So this F and p-value you should never be looking at because it's our block and we don't test block. Another thing that we would want to look at was our interaction plot. So we just went to the ANOVA table. Our next step after seeing, oh, interaction is significant, is we want to look at our interaction plot. So we're going to scroll to the right and we're going to go to where our interaction column is. You're going to click on the red arrow. You're going to go to plot. You're going to go to create an interaction plot. And then we're going to choose the term for overlay. And that's going to be our block term. And we're going to press OK. And so we get this. Another way you could do this is you can go here. You could create a column for your estimated means. You could go to graph builder, and you could build it the same way that we saw in lesson 3's video. This is more of a quick and dirty way, just if you wanted to see what it looks like, kind of a quicker way to get our answers for our homework. After looking at our interaction plot, we saw that it was co-directional, and so if we were interested in looking at just the effect of alcohol, we would then start to look at the main effects plot. And so how we do that is we now go over to our alcohol, which is our treatment for this. We're going to click, and we're going to click plot. And then boom. And again, this isn't the prettiest of graph. If you want something prettier, I would recommend going here, creating a column of your estimated treatment means, and then using graph builder to make something a little bit prettier for maybe a paper or whatnot. Now, our next thing or object that we covered in class was contrasts. And so let's go to that example just to remind ourselves what we were trying to figure out. Here it is. Okay, so researchers suspected that the reaction time depends linearly on the alcohol levels, and so we were trying to determine if the slope of treatment 1 to 0 is the same as the slope from the treatment with 2 ounces and 1 ounce. So does this slope and this slope look the same? Now recall when in our class notes we went over how we got this -1 to -1. All we did was took these terms and moved it over. Now another thing to note is that right now our contrast coefficients are 1, 2, and -1. But watch this. If we were to go do this in JMP, you're going to click on alcohol. You're going to go to contrast. This should be familiar to what we did in our previous lessons. If we did minus, plus, minus, our contrast coefficients are 1/2, 1, and 1/2. And the reason for this, and this is allowed, these two would get us the same thing for our F statistic and our p-value. What would change is that L is because these contrast coefficients, you can either multiply or divide by a scalar. And so all we did was we took our 1, 2, and -1 and divided by 2, and that's how we got here. So we're going to press done, and we're going to notice we have our F test and we have our T ratio. Again, in class, I did mention how we could have taken our alpha 1 minus our alpha 0 and brought it to the other side. What that would have changed, let's just look at it. Right click, contrast. Now we're going to go positive minus positive, done. You'll notice that the F ratios are the same, but what's different is our T. So our T ratio is a +5 here, our T ratio up here is a -5. All right, now the last thing that we covered was talking about the treatment effect within a block for a contrast. And so our question, let's go back down to our question. Our question was, the researcher suspects again that there's a reaction time that depends linearly. So we're still looking at, is the difference between treatment 1 and 0 slope the same as the treatment 2 and 1, but we're only looking within the third age group. So if we went back up here, we're only looking at this green line compared to this green line. And how we do this in JMP is we're going to scroll over to our interaction area again. We're going to click on the red arrow, click on contrasts. Now, I want you to be very careful, and we have these numbers, and sometimes it can get a little bit confusing, especially if we didn't have 0, 1, 2, if this was 1, 2, 3. But how you read this is the first number is going to relate to this first variable. So 1 here, 2 here, 3 here is relating to the group. Then the second number is going to relate to the alcohol. And so again, we were looking for the contrast within the third group. So we're going to go to the third group and we're going to apply our contrast, hit enter, and we can see that we get the same results that we saw in our notes. Lastly, what you might want to also do is you might want to look at your Tukeys, and this is very similar to where you can go to Tukeys HD or the Fishers, very similar to how we've seen in the other lessons.